Yes, so this is the first problem of today's div 2, and in this problem we are given that there is an array n, and basically we have an operation in which we can choose any k such that 2 to the power k is more than equals to 2 and it is less than equals to ai. Like basically we have to give some value from ai to aj. Like, let me explain it. So we have an array a. We want to make all the values in this array equal. So what is the operations that we have? We have operations like we can select I in j, and then from this I we can shift some value to j, like to the jth position. The only thing is we can shift only something which is 2 to the power k, and this is between 2 and less than equals to ai. If we cannot make this value negative, so we just need to find that whether it's possible to make all these values equal or not. So first of all, is the problem statement clear? Like what we have to do. Okay. So now how to do this? See, what is the lowest value that we can shift? It is 2, right? So first of all, we need to find what is the total of this. And one case is when this total is not divisible by n. If this is not equals to 0, then we cannot divide this total among all the n values, right? So at this point only, the answer is going to be no, right? Otherwise, if total can be, let's say that this is average value. Average is nothing but total divided by n. So we just have to check that eventually what should happen. Each and every value should be average only, right? If each and every value will become average. So we just have to check what is the difference between this current value, that is, let's say, the current value which is here, and average. If this thing is a multiple of 2, like it is either 0, it is an even number, it is anything like this, then yes, we can bring this value to average. Otherwise, if it is something like 1, 3, or 5, we can never bring it to average. Why? Because we are allowed to do operations which are in which we can shift values which are something like 2 to the power. So this is the only thing that we have to check, that the difference is uneven. Is it clear? Okay, so let me show you the implementation. So this is the implementation. In this, I have first taken array as input. Then I have found the total value. If the total is not divisible by n, then simply print no. Otherwise, find the average value. This is just a flag. So just check for each value that the absolute difference between e and average is a multiple of 2. Like it's an even number. So if the flag is 1, we can print yes. Otherwise, the result is no. So nobody is having doubt in this, right? Okay. So let's go to the next problem. So in this next problem, we are given that we have an odd integer n, and we just have to find two integers x and y between this range such that x or y multiplied by x XOR y is equals to n. And there are 10 to the power 3, I think, 10 to the power 3 test cases that we have to answer. So see, we have to find any two integers x or y multiplied by x XOR y. This should be equals to n. So first of all, it's given to us that, okay, what happens if y is 0? What will be x or y? What will be x or y? It will be x. What will be x or y? X. So this is x square. Now, what if x is equals to y? What if x is equals to y? What will be this thing? It will be same thing, right? X. What will be this thing? What will be this? This will be 0. So complete thing is 0. Now, like this, we can see that, see, n is odd, right? N is odd. So anything like this will be the binary representation 1 0 0 0 0 1. But the last bit will be 1 only because n is odd, right? So from here you can see that all the bits which are common in x and y, will be set in this thing, right? Will be like unset in this. So what we can do, we can have probably y as this and x as this, the exact same thing, but the last thing is 0. So see, the OR result will be complete n, and this thing will be exactly 1. So you're doing this thing. Is it like, let me write it again. So I'm saying x can be as n and y can be n minus 1. So by n minus 1 we have made it this value, and x is n, so this is this value. So when I do x or y, this is n, and when I do x or y, you get 1. So you multiply these two, you get n. I'll explain this again. See, since n is odd, in XOR operation, when you do XOR operation, all the bits that are common in x and y will get closed, right? So we can have everything common, like everything is same other than the last bit. So the last bit is only set in y, only set in either one of these. So you will get 1 here, and all the other bits are common only, right? So you will get complete n here. Like this is complete n, one of these is n, and the other one is n minus 1. Is that clear? Yes, no, anything. If it's clear, we'll move to the implementation. Otherwise, okay, it's clear. Like, let me know in case anyone is having doubt. Don't wait for others to ask your doubt. So this is simply this thing. Like for each test case, just take n as input and print n and n minus 1. So let's go to the next problem. So in the next problem, we are given that we have an array and we can do two types of operations. The first operation is we can do p times, we can pick any two elements and remove those from the array and insert x plus y into the array. The next operation is, that is this operation, we can do it a q times, and we can delete, like again, we can select two elements from the array, we can delete those elements and insert x minus y into the array. Okay, first of all, is my voice breaking? For anyone? Okay, it's not breaking. And is anyone feeling that my voice is low? It's perfect, right? Okay. So in this problem, we're given that we have an array and we can do p times, we can select any x, y from this array and we can insert x plus y back, remove these two. And we can do q times, select any x and y and insert x minus y. So first of all, what we have to do is we have to maximize, like finally we'll get a new array b, we have to maximize maximum in b minus minimum in b. So see, once we, let's say we have sorted our array, this is the minimum value in our array, this is the maximum value in our array, this is the original array A. So right now we have, if if we give this thing as the result, we have max minus minimum, right? Now after this, we have to somehow do p operations of first kind and q operations of second kind, and we have to increase this as much as we can, right? Currently the array is sorted like this. This is what we have to do, right? Yes, no. Okay. Now see, probably we have sorted this, so this will be negative, negative, positive, somewhat maybe 0, then positive, positive. So my point, like, try to understand that all of using all of these p and q operations, all of these, you can increase this range. How? See, if you have a positive, what you will do, if you want to use this p operation and you have this positive element, you can add this to the maximum element that you have right now, and it will shift. Let's say if it was, this was 8 and this was 10, this 10 will shift 8 further, like it will become 18. So eventually you have added 8 to your result, right? Whatever your answer was. Or what you can, like you can do this for, but let's say you didn't had this operation, you only had this q. So you can also do it like this, take this positive element, and this is your x, this is the lowest value, and this is your y. So subtract from x this positive element. So if you subtract this from this, let's say this was anything. It can be negative also, -5, or it can be 5 also. Eventually it will become -5 -8 or 5 -8. In both cases it will get 8 in left direction. It will go further 8 in left direction. So in that case also you are adding 8 to your result only. And this can be done for negative values also. If you had the positive, if you had this p, then add this to here. And if you had this operation, do it this, like make this your x and this is your y. So x minus y is nothing but x minus minus of negative. So this is, you are adding this much value to this. So eventually for each of these p plus q operations, you have to pick out the maximum elements that you can, because see, if you have the array like this is minimum, this is maximum, and you have -3 here, -8 here, -3 here, 1 here, and 10 here. So first of all, see, if you take this as your operation, you will have 8. Like currently your result is max minus min, and you want to maximize this using these p plus q operations. So if you take this, apply operation on this of any kind, you can apply the pth operation also and qth operation also. So instead of taking p and q differently, I'll take total number of operations. So if you take this, you'll get 8 added to the result. If you take this, you'll get 3 added to the result. If you take this, you'll get 1 added to the result. If you take this, you'll get 10 added to the result. If you have to do, let's say, 3 operations, what should be the order? First you will do this, then this, then this, and then this, right? So first you will take 10 into consideration. Then you will add 8, then 3, and then 1, right? Yes, no, anything. Okay, so what is the final result? Maximum minus minimum plus the maximum absolute values, like the maximum absolute p plus q maximum absolute values. You'll add this much maximum absolute values. Is it clear why we are doing this? And what about others? Is it clear? Yes, no, anything?
Yes.
Okay. So I will show you the solution. So this is how you can implement this. First take n, p, and q as input, then take array a as input, then initially first sort it. So first your answer is the last value, that is the maximum value minus minimum value. Then for each of the values, just take the absolute values. Why? Because we are just concerned about now the absolute values which are in between. So now if your n is between 2, again sort your, like this is one of the ways to do this. So again sort these values from first index to n minus 1th index, n minus 2 index, and then these are your total operation p plus q. Then for each of, if you don't have any operation, then break. Otherwise just keep adding, like I'm going in reverse direction from n minus 2 to 1. Just keep adding this to your answer, and finally you can print your answer. Is it clear? Is this thing clear?
Yes.
Okay, so now going to the next problem. In next problem, we are given that in a distant land, a mischievous, so there's a witch that needs to kill n people, and there are some friendships x and y. So she can kill, the witch can kill 2 friends, like in this order only, when ASI is less than or equals to ASJ. And there is one more thing, that the friendship is transitive. Like if x and y are friends and y and z are friends, so x and z are also friends. So let me see. There
Can
are
you
some
explain the
friends.
problem?
What?
Explain the problem statement again.
Yes, yes, I'll first explain the problem only. So we are given that there are like friends like this. This is friend of this. This is friend of this. This is friend of this. So if, and for each of these, we are given some AI values for each of these. Like A value, what is the strength of these? Now, the which wants to kill all of these, but if let's say 1, 2, 3, 4. So if 2 people are friend, like 1 and 2 are friend, and 1 is having a value 3 and 2 is having a value 1 strength value. So first, second friend should be killed, and then the third friend should be killed. And if let's say this is also 1, so then first, so if this is also 1, then either third friend can be killed, either this order is okay or this order is also okay, right? So we have to count all the number of orders in which the witch can kill. Is the problem statement clear?
Yes.
Okay, so now see, for this is nothing but this is a graph, right? This is a component, connected component of your graph, and let's say this is 4. So if this is the connected component of your graph, what is the order? Order is nothing but first you will have the people which are having the lowest value, that is the ones. Then you will have the people which are having strength as 3, and then you are going to have the people which are having the strength as 4, right? This needs to be followed because each and every in this is friend only, right? I like 3 and 4, like this first and fourth person are not connected directly, but they are friend because the friendship is transitive. They have a this too, right? So this is the final order of the strengths, right? Strengths order is this only for this component, right? Yes, no.
Yes.
Okay. So now you just have to count how many ways you can have these one arranged. These. So if there are two people, there are two factorial ways, right? There is only one person, so one factorial and one. So number of ways to arrange people in this component is this thing, right? Yes, no. If there are
Yes.
5 people having one, so then you would have 5 factorial. So number of count, it is nothing but the number of persons that are having the same strength. They can be arranged among themselves, but all of them will be before some other people. Like you cannot merge this 3 strength people with this. They will be different only, but this is nothing but count how many people are having this much, how many people are having this much, and how many people are having this much. Is this thing clear? Like
Yes.
I have a habit of writing factorial like this. So this is nothing but this factorial. I have a habit of writing it like this. So now, once you have done this, so let's say there are two components. This was having 5 people, some order of, and there is next which is having 4 people. So you have found the number of ways you can order these people, and you have found the number of ways you can order these people, right? But now the total people are n, and now how to order these? Can someone tell me how to order these? Like this is a very classical problem. Assume that you have two
Yes.
arrays and you want to merge these two arrays, keeping their relative order same, right? This is what we have to do. Once we have found the total number of ways to order this thing and number of ways to order these people, we just have to combine these two, keeping their relative order same, right? Yes, no.
Yes.
So this you can see this as an NCR problem, number of it. So if we have an array of size 9, so from this 9, if I choose any 5 places, any like you can do N9C, any 5, like for any of these places I choose, like let's say these are the 5 places that I choose. So the other 4 places are already fixed for this one, right? So number of ways to arrange, like merge two arrays of size n and m is nothing but n plus m c n, or n plus m. You can find anything. Like anyway, NCR. What is NCR? It is nothing but NC n minus r. So that's why you can do either this thing or this thing. But why you can do this thing, is this thing clear? Because you can assume that you have an array of size n, and after that you have to n plus m, and you out of that you have to select any n positions for the first array, and because the order will remain that only, and for the second array the remaining m places are left. Is it clear? Yes,
Can
no.
you again?
Like which part?
Like this n plus n cn?
Like if you have to merge two arrays, combine two arrays such that their relative order will remain same, you can assume that you have a bigger array of size n plus m, and you just have to choose n places out, n places in that array. So the remaining places will go to the second array. Is it clear?
Yes. Got it.
Okay. So let me show you the implementation. So in this, I've first taken n and m as input, then I've taken the graph as input, then these are the values. Then simply, like I'm doing DFS, this is simple DFS code, and I'm just marking which all vertices are being visited in this DFS, like current, which all vertices belong to the current component. This is factorial, and this is just count, like how will I get? So let me show you here. So if the current node is not visited, I'll clear this vector, perform my DFS. Once I return from here, this vertex, like this vector will have all the vertices which were part of the current component. So for that, I'll first count how many times AI, like this value appeared. From that, I will include in my answer, like I said, factorial of that count, and I'll keep taking mod. Now this SZ is another vector, and that is having the size of each component. Like because I have to merge those components also, right, later. So for that, just take total, like starting at beginning, total is nothing but the size of first component. Then for all the components, I'll keep combining those. So NCR total plus this thing, that is n plus m c n. So NCR of this, take modulo, and then now your array is of bigger size. Like what I'm doing, see, you had 5 components of size 3, 5, 2, and 7. So first combine these two. What is it? 3 plus 5, C, 3. Now you have an component of size, like or array of size 8. So now combine these two, 8 plus 2, C, 8. So now you have an array or component of size 10. So now combine these, 10 plus 7, C, 10. So this is what I have done. Finally, you can print your answer. Is it clear?
Yes.
Okay, what about others? Is there any doubt or?
I am the only one.
No, you're not the only one. There are others also. I'm audible, right? First of all.
Yes.
Okay, like I have, okay, so perfect. So, he has responded in the chat. Okay, so that's it. And thanks for joining. Bye-bye.
Bye bye.